So, myself, I'm a practitioner, a long-time practitioner in the monitoring and analytics space. And today, what we are going to talk about is build versus buy decisions, right? Should we essentially buy products? Should we try to build our own products, particularly in the monitoring and analytics space, right? So, as we go on, just a little bit about my credentials, right? I've spent about 15 years in performance engineering, right? All around DevOps, analytics, enterprise architecture. Have worked in a lot of spaces, Java, .NET, Node.js, building apps, APIs. But I got my expertise working at a small company called Wiley Technology, which went on to get acquired by CA, and the same people created companies like NewRelic and AppDynamics, and it's a small world. The whole idea here is like that's where I focused, gained my specialization, so I know the space very well, and I'm going to bring my experiences from a community perspective as to what products I have seen in the last 10 to 15 years, what has worked well for my customers. I was doing a lot of consulting and solving performance problems at Fortune 500 companies, right? So what has worked, what hasn't worked, what should you really be doing, and we'll keep it an open forum, right? So before I go further, right, here's kind of my point of view. Scale, right? Data scale isn't the problem anymore, right? That has been solved not just with the design of all kind of big data systems, and those have become the back end of monitoring. However, there are this whole emergence of non-SQL databases, and they have their own ways of horizontally scaling as well. So scale isn't the problem anymore, right? It's the context of the data, and the context traditionally is in respect of time, but it's also in terms of correlation, right? Hey, what other data points is this data related to, right? And that's very, very useful when you are down the triage process. And I'll go, give you some real time examples. um, what I have found out or kind of realized over a period of time, right, is that time is essentially the lingua franca. If I am working on a performance issue, or even if I am working on a customer issue, or they need visibility in real time, if I lose that window of time, that data isn't useful anymore, right? Or maybe it's useful, but it's not as valuable. So latency in getting the data is, it kills, right? So freshness is critical. And we can be talking technology terms like, hey, I'm going to do this using events, I'm going to do this using logs, transactions. End of the day, they don't really matter. What matter is, can I get my right metrics, and can I get those right metrics in terms of and in the right context, right? Other things are like means to an end, right? And can I get them simply, right? I don't want to go spend my time solving installation issues. I don't want to get into complex architectures and so on. If I have to do all that, why not build my own system, right? So if I'm using so many vendor products, right, complexities and dependencies, they essentially crush the time to value, right? My experience should be smooth. Enterprise software is getting consumerized, and I should have a similar consumer experience, right? So, what my experiences have told me, and these are real world experiences, this is kind of a firefight scenario, right? I got this picture from one of my colleagues. We were working in SWAT teams, and they were trying to diagnose an issue. And you can see that there are people working on different teams in different silos, gathering over some guy's laptop. Uh, the point is, like, their point tools did not work in a team environment, right, when really needed. Every of their point tools was telling them a different uh, answer, and they had to gather around one guy to really get to the root cause. So just some statistical number. This is not my research, right? I grabbed it of somebody else's research, but just an operational landscape, right? This was a survey done. Hey, you know what? If you're looking at traditional enterprises, nowadays you're running 1,000 to 10,000 physical or virtual servers, and with containers coming in, that number is going to become insane. right? Because containers go up, they are short-lived, they go up and down, and you spin up more on demand. So, there are no more static assets. More and more virtualization is pushing in. And, you could be looking at up to 5,000 network components, hundreds of applications, right? Multiple data centers, more than, 200 or more storage components. Now, to monitor all these, traditionally, if you look at a survey, every enterprise has 10 or more tools. Like at least 30% of enterprises have 10 or more tools, and you're getting more and more siloed, right? Um, Culturally, we are shifting the other way, right? We are moving towards DevOps, where developers and operations kind of work in a single team, or sometimes they actually are the same person, right? You are doing continuous integration, continuous deployment, and you are not really going down the waterfall model anymore, because you need to make releases quickly, build quickly, and deploy quickly, test quickly, and rinse and repeat over and over again, right? Having so many silos based approaches doesn't really work. And from my real time experiences, right, resolution, right, what happens is whenever there is a triage, that I'm conducting for a production problem or whatever, right, we normally just quickly fix the system, reboot it, bring it back online. It's really, getting to the root cause is often takes a long time. You need subject matter expertise, and 9 out of 10 issues don't really get to the root cause, right? You kind of get a mean time to restore. You don't really have a mean time to resolution that is like very optimal, right? So it takes you days to figure out what was going wrong. So all these is challenging. So what's happening is multiple vendors, right? They have addressed this space, right? For the last 15 years or so that I've been working in this space. So from the data center monitoring perspective, right, holistic monitoring, there are some players, right? There are many more. I just listed a few well-known names: IBM, CHP, Dell, BMC, CompuWare. And what they're trying to do is build a solution which is called as a manager of manager, right? So, for example, CA had a solution called as Service Operations Insight. BMC had its own, dashboards based on Patrol and BSM, and HP had a Business Availability Center, and so on. The whole model could be architecturally represented in a single snapshot like this, right? There could be variances, but this is essentially what's happening, what every large vendor is trying to do. So think about your landscapes, right? You have applications, you have different layers, right? You have the network, the virtualization, the server layers, the application layers, the edge layers. And within the edge, you have, your edge network devices, your mobile devices, the APIs that you are rendering. Within apps, also, you could be deploying it to your private data center, to a PaaS environment, to a cloud, or maybe some A/B testing environments, and so on, right? And you could be over multiple network locations. So what's happened is traditionally you had a tool for any of these layers, right? So hey, for mobile monitoring, if I were gathering crash analytics and API analytics, I had a tool for mobile monitoring. Similarly, if I were able looking at applications, maybe I am running a Java stack, right? And I have JVM tools, or maybe .NET stacks. I had .NET monitoring, CLR monitoring tools, or maybe I had log parsers, right? Or maybe I was doing synthetic transactions, so I had all kind of cloud-based pinging tools, or maybe just synthetic tools that I use within my data center, right? And on the infrastructure side, maybe I was looking at packets, or maybe I was looking at servers. So you had these tools, right? The green tabs here, they essentially represent different tools within different silos, right? So you could see easily here we have more than around 9 or 10 tools, right, for each of these silos. And the original approach was, let's try to aggregate this data, correlate this data, right? So you came up with a common service model, and you tried your best to make your tools integrate using an API with that service model, right? And you came up with a manager of manager, which was further integrated into service desk system or reporting systems and so on. Problem is, it looks good on paper, and I have myself implemented a few bomb solutions. So speaking from experiences, they don't really work very well without heavy investment and heavy maintenance, right? So and think about it logically, right? Integration of silo tools is complex. These tools were not written by the same engineers. They came through acquisitions. They came through different teams, right? They did not were not engineered keeping similar data models in mind, right? And during integration, certain components upgrade, right? You have breaking changes. You need to go through an expensive integration and upgrade process. But more importantly, the metric schema and the protocols are proprietary and incompatible with each other, right? So, hey, you know what? As an example, maybe when I'm gathering packet statistics, packets are coming in streaming, and but however, to compute metrics on that, I need to aggregate for at least about 5 minutes, right? Because I'm dealing with a 1 gigabit per second pipe, right? And I have to compute the packets, look at the headers, get the information, correlate the information, and then create metrics of it. However, maybe I'm working at the application level where I have an agent, and this agent is looking at all application code that's getting executed, and I get metrics every 15 seconds, right? So it's difficult to correlate a 15-second metric with an aggregate 5-second metric. And the 15-second one is probably at the app layer, the 5-second one is or maybe a minute one is probably at the network layer, and because these tools were not written by the same guys, right? So their models are different. Data retention policies, right? How do you roll up the data? Aggregation, those could be different and difficult to sync, right? Storage solutions, you don't have common storage, you don't even have common data schema. Some of them might be storing in the cloud, some of them writing to disk, some of them in memory, right? So how do you get to a common storage model? And when you start querying, all this correlated data, which is in different silos, it takes time, right? It's not real time. And maybe you don't even get some data points. So end of the day, the vision looks good on paper, doesn't really work unless you have like full-time subject matter experts sitting there and um, maintaining this and keeping it up to date, solving all the chinks as you go along, right? So newer monitoring stacks, as we see, newer vendors or maybe even existing vendors have started retooling, right? It's on the right track. So now they have started getting into these messaging type architectures where you could be pulling metrics from agents, polls, synthetics, logs. Every data source kind of pushes or publishes data to a data collection queue. If you're consuming from legacy sources, maybe you have to transform the data, do some ETL jobs on that, and then get it to the same queue. And maybe you have a common metric store and a common event and aggregation store, which kind of subscribe to this data collection queue chain, right? And if you want to pull analytics on those, then you and do some visualization. You can pull from both these metrics and event stores. Again, in a pub sub based model, there is no single persistence layer. If you're working on a mobile and a web visualization, again, you can do that. But the visualization component is totally separate from how you access data, right? And on the data collection queues, now if you want to do some machine learning, detect some anomaly patterns on that and create alerts, or even just do reporting, you essentially pull right off the data collection queues. So if you are familiar with Influx, you will see that a lot of these components start mapping, right? So we have agents, or basically we have a telemetry solution, a bunch of agents, plugins, log parsers, whatever, which kind of gets into this bottom layer, right? Data collection, you can think about it. This is essentially your Influx toolchain, right? InfluxDB toolchain, including the metrics, storage, and aggregation, right? The anomaly piece is done by Capacitor. The visualization piece, we provide some of it using Chronograph, but we also have other open source tools called Grafana, which handle that. And alerting is also done by Capacitor, right? So you kind of see, the basic components of the stack, right? So now people are coming to a common model, and again, the thing is to be careful here. The gotcha is that they still need to gain maturity, right? Although some vendors have really perfected this, but if you are going too broad, right, a lot of times you kind of miss out on the depth, because individual siloed tools were very good when they were doing deep monitoring, but you could not integrate well enough with other siloed tools who were doing deep as well. But maybe newer companies who had limited engineering resources built a very good data correlation model, but they still have to mature a little bit on the depth side. So I'll not point out names, but just something to keep track of. So, just looking at some of these different areas, right? We talk about the holistic monitoring. Let's break it down, right? So if you're looking at APM, APM essentially stands for Application Performance Management. The players in this space are, Wiley. I used to work for Wiley. Wiley CA, APM, CompuWare had a company called Dynatrace. You had HP's APM, IBM's APM, NewRelic, AppDynamics. These were the newer players, right? Most of these, there can be obviously exceptions. Most of these used an agent-based heavy instrumentation technique. In Wiley days, we used to call it bytecode instrumentation. So essentially what you do is, if you're looking, for example, at a Java application, you essentially create an agent, you have a couple of jar files, you drop it into the class path, and as the code executes, the agent injects probes into the application code, the compiled application code, not the source code, and then reports back metrics. So that's good. And with this, because you are tagging all these applications, you can start doing transaction tracing. So you can inject globally correlational IDs into your servlet headers, try to decorate the headers, stitch them together, and do some kind of transaction tracing. So as the transaction comes in, goes to the web server, the app server, multiple SOA tiers, hits the database, you can actually see the transaction, track the time, right, end to end. But end to end is kind of over promised, right? It's not really end to end, because you can't really instrument too much on the database server, right? You cannot really instrument too much at the infrastructure beyond. Maybe you're calling some third party service. You could get very good tracing. You can look at what's executing on the actual application server and what are the external calls they are making. So you can look at code profiles very well, right? But end-to-end tracing is kind of not there yet, right? So some gotchas to watch out for. It's often depth versus breadth, right? So the guys who really do tracing very well, a lot of times, they're looking to cover the breadth, right? They kind of fall short on how deep they can go. And breadth is good, but when I'm really doing root cause analysis and I have a SEV1 issue or a SEV2 issue, I don't care about fancy correlation charts that you're getting me. I really need to get into the depth, right? Can I get into the JVM, or if I'm doing a .NET system, can I get into the CLR? Look, or maybe I'm using a Golang application, right? Anything that's running in managed memory, or maybe a Node.js application, JavaScript application. Can I look at the garbage collection statistics? Can I look at the thread statistics? I really need to go deep, right? Just telling me that the transaction goes from point A to point B and it's taking like 6 seconds is not helpful. That points me at the right direction. It's not good enough for root cause analysis, right? And keep in mind, right, when you put in heavy instrumentation or agent-based technologies, it's not free. It comes at a cost, right? And that cost is overhead. When you turn on transaction tracing, or even if you just put your agent, the agent has to execute code, right, along with the application, and it burns additional CPU cycles. So that comes at the cost of overhead. There is no zero overhead system unless you are doing totally passive monitoring at the network packet level, right? And even that is like, I can't say there's 100% zero overhead. There is always, even if you do some spanning of packets, right, and analyze them, there is a little bit overhead involved, right? And it's not really the metrics, it's subject matter expertise. So don't just go in and say, oh, I'm getting like 5,000 metrics here. Those metrics wouldn't mean anything if you really didn't have the understanding and of how to, what those metrics mean for your application, right? So we have this concept of app maps where we do this mapping. Oh, application A calls application B, calls servlet C, calls blah, blah, blah. And you have like, you're spending 5 milliseconds here, 10 milliseconds here. That's fine. That's for a transaction sample. It doesn't, if something breaks here, I can go look, at a point, it points me at the right direction, but it's not enough, right? So they are not really silver bullets. They are good pointers, right? So another thing to solve is last mile monitoring. So what happens is most performance agents, they don't really instrument your application logic, right? They instrument your key performance indicators. You could, right? You could instrument each and every bit of your transaction and get metrics, but then walk away with 70, 80, 90% overhead. So what happens is, hey, you know what? As classic example, right? And you miss out on a lot of instrumentation once in a while, right? So you start seeing anomalies. So as an example here, I have a buy transaction and I have an add to cart transaction. And what's happening is this transaction is hosted on a container, and the container is running a microservice. And I am essentially, getting the CPU user time. Maybe I'm not getting CPU cycle time. Maybe I'm not getting temperature. These are the missing ones. I'm getting memory metrics from the application running in the container. Let's say I'm getting garbage collection metrics, but I'm not getting memory deallocated metric, right? Or maybe I'm not on the network type. I'm looking at the reads and the writes, but I'm not getting like the computed latency. So maybe I'm missing these key metrics. On the database side, suddenly I start detecting anomalies, right? And this is stuff I'm monitoring, and I'm seeing that, hey, response time jumped and the query time jumped, right? So this is abnormal behavior. But if I were looking at the database only, I could be guessing, right? What's missing is this correlation saying, hey, you know what, this jumped because, and what that abnormal behavior on the back end did was cause, increase the latency of the container service to talk with the backend, which in turn resulted in the spike in the transaction, right? So you can try to do it. It's a oversimplified use case. But again, if you are seeing here that query time jumped and response time jumped, you still don't know why, right? You really have to look at, getting the data from other tiers within the database. Look at database operation, logs, and maybe it's something to do with the network, because you see a network latency here. Maybe you should check the network performance or the IO rates on the database itself, because most databases are IO dependent, right? So this could be missing instrumentation, which kind of causes a lot of pain point. And this is also called as custom monitoring. So what a lot of developers have started doing is, hey, guess what? I'm not going to leave anything uninstrumented, right? I'm going to start custom, writing code annotations, annotating my code, my methods, everything that's critical for me to know about, right? And I'm going to create metrics. Maybe I don't use agents at all. Maybe I just log all those metrics, right? What I need, and that gives me the key visibility of what's happening when. Maybe I use them as complementary, right? The agent kind of gives me the key performance metrics, but maybe all these metrics that I care about from a logic perspective, I just log them, right? So there are different ways of solving this problem, but this is last mile monitoring is most painful, right? So just some advice, right? So most metrics at the system level, right? Web server like Apache Nginx, container like Docker, CPU, disk, memory, even database basic connection level metrics, network, if you're pulling network devices, SNMP, all of them are cheap to obtain. You don't really need heavy agents. There are a lot of open source options, and a lot of these devices and applications kind of publish APIs, right? So if you wanted to get Apache metrics, for example, Apache publishes its stats on the module, right? It's called module stat.stats, as well as you can parse the Apache logs, right? So a lot of log parsing frameworks available. You don't really need an agent to get that metric, right? So it's kind of oversold what's really valuable, what's not. Deep instrumentation metrics are very useful, particularly for root cause analysis. And there are, sometimes you need to buy off the shelf. Sometimes there are alternate and cheaper solutions, right? So if your developers want to instrument everything, they want to annotate code, you can just get away using logs. You don't really need to buy a lot of agent-based technologies. But again, whatever you do, keep in mind that use a common data format, right? If you're instrumenting all these layers in your stack, right? Maybe you're instrumenting your network, maybe you're instrumenting, you're using SDN switches, what it is, or you're essentially pulling metrics from whatever layer. For the storage perspective, for the visualization perspective, use a common data platform. And that data platform happens to be time series, right? I don't think we need to argue or discuss about that anymore. If you are still in doubt, you can watch some of the earlier webinars. Time series is essentially the common data format that most even monitoring vendors are building their tools on. Right. So if you look into the infrastructure and the network monitoring side, again there are players here, right? HP, CA, BMC, IBM, SolarWinds, Nagios, Riverwed, whatnot. And most of these solutions are using SNMP, or sometimes they use network packet capture techniques, right? So, hey, get me a span port on your load balancer or one of your server switches, and just get all the packets going over that switch, and I'll figure out from that packets, and I can get tap multiple points, and I can essentially get you, round trip time. I can tell you like what the server performance at every hop is. Or maybe I just do SNMP based discovery. Most network devices have some kind of metrics that they expose over SNMP, as long as you can poll them, right? So if you have the MIB information, you can poll the SNMP table, you can essentially get back performance metrics, right? So all these solutions are there. They've been there for a while. Some gotchas here, right? Although you need this, right? Absolutely, you need this. I don't know whether you should buy. It's actually very easy to build these kind of infrastructure monitoring solutions. Um, the main problem is most of these legacy vendors, they are finding it very difficult to keep up with newer virtualization techniques. Like if you're talking about at the network level, software defined networks are here, right? They're not like long way off. If you're talking about infrastructure virtualizations, VMware is having a hard time now because containers have just taken over in the last couple of years. Everything from Docker to Mesos, and the next 5 years is probably going to be the container technology world, right? You might not have VMs anymore or LPARs anymore. So it's hard for all these guys to keep track, right? And these are not static assets. So just simple SNMP based polling or packet discovery may work, may not work. Maybe you can make it work the hard way, right? And it has, in infrastructure network monitoring space hasn't seen as much pace as innovation as the app space, right? And that's kind of normal, in the last 10 years or so. So now people have started coming up with specialized solutions, right? So if you are, let's say you're deploying OpenStack. So what happens is, hey, you know what? And this is from a vendor who actually goes and deploys OpenStack solutions. So OpenStack has, for the compute ones, you use Nova, and there are other orchestration layers. So there is a storage tier, there is a compute tier, there is a control tier. And what they have done is started instrumenting, right? Instrumenting using APIs, instrumenting using log parsers. And you can see here, this is a reference architecture where they're sending all these metrics, the time series metrics into InfluxDB, and the event metrics into Elasticsearch, right? And visualizing that with Kibana, InfluxDB metrics were visualized with Grafana, right? So this is kind of a custom solution reference architecture, right? If you're looking at containers, this is another one. I talked about this in one of my earlier talks as well. This is a very large telco. They have built a custom solution, right? Because nothing out of box kind of gives them that flexibility. So this is not just monitoring, right? So it's kind of a scheduling system. Mesos does the orchestration. You're orchestrating containers on demand, and you're running tasks. You're deploying microservices. You're spinning up Docker containers. Docker now ships with a library called a C Advisor, which gives you all the statistics, all the key performance metrics from within the containers. And C Advisor has an integration into InfluxDB and maybe some others as well. And in this case, they use Apache Spark, which is a general purpose analytics platform to grab metrics from InfluxDB and do some kind of run some kind of large scale analytics jobs. And obviously, the state of the cluster is persisted back into Redis, and based on how the state changes, the scheduler kicks off again and goes and provisional additional containers or demand or whatever, right? So this is essentially an automation, end-to-end automation solution, which helps them continuously deploy, right? Do a CI/CD solution and a very agile process, right? Now you could say, hey, you know what? I want to monitor all of these using out-of-box tooling. Yeah, you can, but do you really need to? There are open source solutions out there. Unless you don't have absolutely any engineering muscle, just go buy off the shelf, right? But even then, you'll have to depend on the vendor to keep up with everything. So anything you're trying to be innovative and create custom stacks, you should start looking at some of these open source technologies. So just some advice, right? Metrics at the server, container, and network device are cheap to obtain. Use APIs. Most devices have APIs. Most devices support SNMP. And SNMP, I'll give you some examples. We have a agent technology called Telegraph, which is totally open source, and it has an SNMP plugin. So go, poll anything SNMP v2, v3, you'll get most metrics for free instead of having to buy, a product solution. For packet analysis, that's kind of the complex stuff. Maybe you should buy off the shelf, unless you have some engineers who really understand packet technologies and how to decipher packets. I've used Wireshark, but you cannot really run Wireshark all the time, right? You need some constant packet monitoring technology as well, right? But again, similar recommendation: choose a data format and please choose time series, as that is going to be the format going further, right? Uh, Looking at log analytics, again, some players, right, well-known players, Splunk, Elasticsearch, Sumo Logic, Logly, others are coming in, and these guys generally parse application or system logs, right, for metrics. Uh, Not too many gotchas because they're realistically a little newer, right? There's not a lot of legacy tech here. However, you need to log everything, right? So yes, you can read everything from a syslog, right? You have that information. You may not have application information. So recommendation, more than a gotcha recommendation, would be for developers to instrument, annotate code, and log it, right? So that you can use this. However, when you start instrumenting everything, annotating everything in the code and logging it, even there, informational logging is okay, but there should be a little bit of overhead injected, right? Because you are running some extra lines of code, if not nothing else. So you should be, monitoring the overhead. Nothing is free, right? There are no free lunches. And time series is, but again, for just the log vendors, right? Time series is what most of them want to plot against, but the backends that they use are not necessarily time series, right? So you might be using Elasticsearch, which is kind of open full text search platform. Although they could do time series, but it wasn't really optimized for time series, right? So you get some mixed performances. You cannot really scale to a pure time series level, database level scale, right? But kind of that's where this is headed, right? So I cannot call out too many gotchas here. Big data analytics, this is an interesting one. So if you look at big data, right, it's kind of really comes down to real-time analytics. So just some examples, right? If you're doing, let's say, price deal comparison, or you want to look at DDoS or phishing malware attacks, or you're looking at content analytics, or maybe you do presence services. There's a lot of data, right? Tons and tons of data that's coming in. Sometimes this is available in existing big data platforms. Sometimes these are coming in through message queues, right, or just through data APIs, right? Now, if you look at two of the main platforms I might want to call out, so Hadoop is gone, right? Like Hadoop, people have invested, but they have found out it's not efficient anymore. MapReduce jobs take forever to compute analytics, right? So we have already seen next generation open source technologies evolve. One of them is Apache Spark, right? And Apache Spark essentially used DAG instead of MapReduce, right? And if you're looking at the ingestion, obviously they ingest from Kafka, Flume, NFS, Cube, right, and even HDFS. But essentially, it's a pipe, right? You can kind of turn on the fire hose, consume at scale, right? And then some of the components are kind of inherited from Hadoop. But you have machine learning libraries, you have computational libraries called GraphX, you have approximate SQL and as well as in-memory databases out there, and then you can have an API in multiple languages. And once you write your analytics jobs, whatever kind of functions you want to apply on the data pipeline, then you can essentially persist it back into NoSQL database and run dashboards. The problem with this is there are too many moving parts, right? Simply too many moving parts just to get value from the data. But I think it's a step in the right direction when you start building platforms, right? To get your analytics off the data, right? And consume data from everywhere. So you're not limited to what a specific product like an APM product or an NPM or a log analytics product like can do, but you are on the platform strategy. Similarly, Storm, right? Both Apache Spark and Storm kind of claimed near real-time performance, right? So even Storm is getting a lot of adoption where you are again ingesting from a lot of messaging systems like Kafka, JMS, ActiveMQ, even Amazon Kinesis, right? But again, the underlying infrastructure of Zookeeper, Supervisor, Worker nodes, Nimbus, that's kind of all coming from Hadoop, right? So you run jobs on those, but Storm has this inputs called as spouts and outputs called as bolts, and you can apply rules on the data pipeline, and then get that data off, and your bolts will essentially give you all kind of analytic results. You again store it in HBase and do reporting, or you stream it into SQL Hive and so on. So the reason that it's complex, and also another reason that I'm not encouraging you highly to adopt it right away, because these are still have dependencies on legacy Hadoop infrastructure, right? So Storm by itself does not have a database. You will have to go to an HDFS system or something like that. And when you go to that, or you have to run all these jobs, you need orchestration tiers. So it's a massive undertaking. If you have already invested in it, fine, right? Try to look at optimizing it. But if I was starting today to build, monitoring solutions, I would not start with Storm, or I would not start with Spark, right? I will start with something else. So I'll leave you this deck, right? There are some gotchas, and I started doing some comparisons, right? Influx has a layer called capacitor, and Influx has the capacitor is essentially a Spark or a Storm for only time series. Because if all you care from a monitoring perspective is time series data, you don't necessarily care for, let's say, segmentation data or other kind of business data. Why would you create a monitoring system using Spark or Storm, right? In terms of ingestion rates, capacitor, which is the open source analytics engine of Influx, can easily top Spark and Storm. Spark has been benchmarked to do 400,000 messages a second, and Storm, even with the Trident API, can do up to 300,000 messages a second on a minimalistic cluster, right? You might need 4 or 5 servers to get that kind of performance. On the other hand, you could do the same numbers with a single instance of open source capacitor, right? So there are some gotchas here as well, but I would primarily point out too many components, too much dependency on Hadoop infrastructure, and time to get value, and the complexity is very high, right? So, and they've tried to, and again, you can claim real time, but the point is like these were legacy, like these were originally written to handle batch data. So now you are coming, with newer architectures. One of them is Lambda, which essentially, if you are looking at, creating long-time ETL jobs or BI just on batch data, you can do that. Using Hadoop and MapReduce. But if you're really looking at, let's say, more near real time, you can be processing streams, and that you could do, let's say, with Storm, right? So, or maybe even with Spark, which does mini batching. So you are getting to some consolidated architectures. But to me, as a practitioner, right, as an enterprise architect, this is even further complicating things, right? If I already did not have much complication, right? So now I need to handle the architecture for Storm. I need to handle the architecture for Spark, make them work together, segment what kind of jobs I want to run where, and, have another merged view, maintain all these different tiers, right? So, and so the last use case I really want to talk about is IoT and sensor data, right? So, in the IoT world, what's happening is these are some of the known boards, right? Raspberry Pi, Arduino, BeagleBone, Arctic, and so on. However, these boards are lightweight; they don't have much computing power. So all agent-based monitoring technologies, you have to throw them out of the door. They're not going to work anyway. Nor will your log-based technologies work, right? Because you're not running big applications on there, and don't have much CPU. Um, and then there are the gateway players, right, who are essentially sitting on the cloud or somewhere in a near network, right, and trying to make these devices talk over an IoT gateway, have them register through the gateway, and have them send events over a message queue, right, maybe Apache Kafka, and then they want to stream it on the back end in the cloud and give you analytics, right? Now, this is kind of becoming the architecture. For consumer IoT, it's easy, right? You can just do most of the work on the cloud as long as you can stream up the metrics to an IoT gateway. For industrial automation, however, the use case is a little different. You have to do a lot of processing on the edge, right? And maybe you do all localized processing. You cannot really talk to the cloud, right? You are on the shop floor or whatever. And in those cases, you might want to do most of the time series computation and alerting on the shop floor, and then downsample the data and then send that downsampled data onto the cloud for long-term analytics, right, or operations. So in IoT, key things to watch out, right? IoT data is mostly time series. It's not log. I called these out earlier. You cannot deploy agents, due to low power devices. So most processing, right, is on the edge. So and gateways, you have to be careful so they don't lock you in. So the advice here is, right, if you are an IoT developer, if you're writing code, start looking for libraries where you can actually instrument your code which runs on the device, and if you can send metrics from there without using an agent, right? Um, there are a lot of available technologies to do that, but that's how really it's going to scale. But again, from the format, all you need is essentially time series, right? So time series, we looked at the different things, but what are other use cases, right? The future is what realistically I'm looking for. If I look at the past data, even over time, or the present data, it's good for operational purposes. It's not helping me too much from the business perspective. So, we looked at, I talked about this in my earlier talks, right? In time series, there are some live models, right? When you look at different patterns, hey, this is horizontal data coming in, trending data, seasonal data, cyclic data. But this is all this data, it has happened either in the past or it's happening today. So we can plot different time series metrics, right? The interesting bit, things become interesting when you start asking questions, what will happen in the future? So then when you start getting into predictive modeling, right? So there are some questions here, I don't have the time to go through all of these. But you can now start asking questions. Let's say, what is going to be my revenue projection for the next 4 quarters based on what I've been doing, right? Or my infrastructure users was X, and in Black Friday, can I scale up, right? So these are like questions you are really, really important. Now, there are different forecasting models. You can look these up on Wikipedia, moving averages, centered moving averages, exponential smoothing, ARMA, ARIMA, SARIMA, FARIMA, and others, right? So they are very well-known forecasting models. Only thing, you have to be careful that all forecasting models work on time series, right? So if you have a way to custom instrument, not just DevOps applications or systems, but even applications which have business data, right? Or have transactional data, and get that data in time series, then you can essentially leverage the power of all these forecasting algorithms, right? So as an example, here's the result of a forecasting data using an autoregressive moving average, right? So you have annual, a data which is plotted at the actual value, and then you have the average, and then you have the forecast which has been determined using using this algorithm, right? So you can start thinking about this in terms of capacity planning, business, parameters that you want to tweak, whatnot, right? So there are many time series platforms. So what are some of the options? There are some options. We did some benchmarking versus Elasticsearch. And I'm going to advocate Influx, not just because I work at Influx, because just coming from a indie practitioner's perspective, I see that that's kind of what is specialized for time series, right? So in past, people have built monitoring platforms on Elastic. But Elastic was never meant to be optimized for time series. It was optimized for open text search, so which has its own use cases. And so time series never claims to do that. So if I have to build a monitoring platform, I would not choose Elastic, right? I would not choose Cassandra either. Cassandra did not have any time series functionality. I always has to write application code on top of Cassandra to make it do time series. And even if it did, it was more of a columnar store, but a key value pair based database. That's what it was optimized for. From a performance perspective, when we did some benchmarking, Influx came out like way, way ahead of Cassandra, right? And you can read these benchmark results. We have done a couple of talks this week and last week, and these are available on the Influx website as well. Um, just from a stack perspective, if you have to choose it, let me just give you a 5-minute overview of what the stack is, right? So we have a stack that we have been building, a complete open source stack called as tick stack, right? And the same stack, and because I gave you all this background of big data systems or whatever, right? Log analytics systems. If you start thinking, there are 4 key components. There is a telemetry component. How do you ingest data? There is a storage persistence component. How do you store data? There is an analytics component, and there's a visualization component, right? Now, if you can do these all in a single platform, very, very simple to deploy, open source, and you don't really need multiple point products, multiple orchestration layers, and you don't need massive enterprise architectures to do that. Time to value is all we are talking about, right? So if you're really looking at this is essentially a architectural layout of the tech stack. So on the left hand, you see there is a component called as Telegraph, and all of these are available on GitHub. You can check them out. And Telegraph has a bunch of plugins, right, to ingest data. And it persists that data into InfluxDB. Chronograph is a component which helps you visualize it. However, you can alternately also use it with Grafana. Grafana and Influx are very well supported. And we ourselves host Grafana as well in our cloud solution. And Capacitor is essentially Spark or Storm for time series. And it subscribes to the same data pipeline. All of these components work on exactly the same data pipeline. So there is no integration tasks to do whatever. As the data comes into Telegraph, you will automatically, even if you did not use Chronograph, or InfluxDB in the middle, you'll actually see that data come stream into Capacitor as well, because the pipeline is the same, right? And on the back end, for alerting, for automation, for machine learning, these are all the jobs that will be running. These are bolts, essentially, the synologues of Storm bolts that are available in Capacitor, right? So just a breakdown. So if you look at Telegraph, there are about 75 plus and growing streaming inputs for apps, DBs, messaging, sensors, network, and containers. And the community, it's open source, so the community keeps adding 2 or 3 new ones all the time. There are outputs, right? So we just don't output to Influx. It's optimized for Influx, but you can also send outputs to Kafka or AWS Kinesis. And there are 15 other outputs, right? Most of the plugins have been community driven, and it's very extendable, easy to write a plugin. And by the way, this telemetry solution runs on Raspberry Pis and Arduino as well. So there are ARM builds. So it's really, really easy to collect data from lightweight or light powered sensors, right? InfluxDB, the database itself, that's the core product, has an SQL query like language. So you don't need to learn another language. It will, in terms of just pure, I'm plotting 500,000 values per second on a single node. This is inclusive of an averaging of reads and writes. If we were just doing writes, we have benchmarked it to do 1 million writes a second, easy, on a single server. If you really want to scale it across over a large cluster, you get the benefits of scale. And then there are functions like data lifecycle management, built-in aggregation and downsampling, and pre-built functions, right, for monitoring like mean, max, spread, standard deviation, average, counts, derivatives. And you can also do stuff like in-memory analytics, right? So you can create percentiles of data, and all of those you can do as streaming metrics in the database, right? So we call that continuous queries. You can read up the documentation how to do that, but essentially we consume a time series metric and then apply a mathematical function. A lot of these functions are available out of box and persist it back into the time series database store as a metric. And because it's a rule that you have applied, now it's available as a streaming metric and is queryable at any time. So you have in-memory analytics already, right? And all these functions are specialized for time series databases. You will not find them in relational or any general purpose backends. Um, Visualization, obviously, you can look at its graphing, and developer friendly, right? Even if you use Grafana, developer friendly. All the queries are as soon as Grafana or Chronograph point at Influx, all the data is exposed in a data explorer, available as drop down. You don't need to write any complex queries. You can get from zero to dashboards in literally a few minutes. And finally, the analytics layer, which is capacitor. So, it solved the problem of both Storm and Spark, but only did it for time series, right? That's our specialization area, time series. So it did support for both streaming and batch, and it was used for anomaly detection. So you could watch data if you wanted to just put some thresholds on metrics and watch them and create an alert. You can do that, but who wants to create static thresholds? You really want to get a little bit more self-learning, right? So you can have it watch out for sigma variations. There are machine learning libraries that you can port to the system. And we also supported predictive analytics algorithms. So one of them was called Holt Winters. We wrote a blog about that, and feel free to check out the project on GitHub as well, right? And on the back end, if you wanted to do any kind of automation, DevOps automation, send notifications to HipChat, Slack, or maybe trigger other jobs, call APIs, you can essentially have an extendable platform, right? So my recommendation would be look at the tech stack if you're trying to really build custom monitoring, custom analytics, real-time and predictive analytics solutions. And I, walk you through different options. If you've already invested in monitoring tools, big data solutions, fine, right? Don't really have to rip and replace. But if you're doing new projects, look at that. If you start seeing value, my recommendation would be to start. These are not. Try to get 80% of what you need with open source using the platform, and maybe purchase off the shelf software for the really hard to do stuff, right? Which you will not be able to build on your own. So with that, I'll open it up for questions.